For this week's video, I will be doing problem number 3 from section 3.2. And this problem states, find the derivative of p theta, which is equal to the square root of 5 theta. Then evaluate p prime 1, p prime 5, and p prime 3/5. So this problem was tricky to me at first because I was going about it the wrong way. I tried to just look at this number here in the square root of 5 theta and thought that I could just find the derivative here and call it 5, get rid of that what is the theta, and I was going about it the wrong way because I didn't realize that there was a special rule for doing the square root of the derivative. So I'm going to write the rule out first. For the rule for square roots when we're finding the derivative. In that rule, I'm going to use the variable u as my variable for this. So if we have the square root of anything, so u, and we want to find the derivative of that, that rule says that we take u prime all over 2 square root u. To explain this a little bit better, underneath the radical is the radicand, so we take the derivative of what is underneath that square root sign and put it on top, and then underneath we just take 2 times this original number here. So in our problem we have p theta equal to square root 5 theta. So first step is to just find the derivative of that. So I'll put this here. And so again, I'll rewrite the rule on this. We have u prime over 2 square root u. And we're looking for p prime of theta. So we have the square root, let's go down here. We have the square root of 5 theta. So following our rule to find p prime, since that's p theta, p prime theta, we take the derivative of what's under the radicand, so the derivative of that is just 5. And if it gets tricky to have different variables, I usually think of this as either a u or an x, and I know the derivative of 5x is just 5. And then on the bottom, I just take 2 times this whole thing right here. So 2 times the square root of 5 theta. And that answers our first question of the derivative. Find the derivative of p theta is 5 all over 2 root 5 theta. Now, once you have that, that's the hardest part, and now they want you just to evaluate for different values. So we are to evaluate for p prime 1, p prime 5, and p prime 3/5. So starting with p prime of 1, just like if a normal function, you're just going to plug this value in for the variable. And remember, our variable is the theta. So using that, we know that we have, we start with 5 all over 2 times root 5 times, and if we look up here, this is where we're going to plug the number in. So it's going to be times 1, using that 1 there, which then that equals 5 all over 2 root 5. And that's as simplified as we need it to be. So that's our answer for prime 1. Next one we're going to do, I'll label this